A military map is simple and easy to understand once you know how to apply certain basic principles. This man, for example, is in unfamiliar territory. He wishes to identify his present location and plan a route which will take him back to his platoon in a small town some distance away. On his military map, if he knows how to read and use it, the soldier will find all of the information necessary to solve his problem. But before he can be certain that the information he reads from the map is correct as it relates to his present position, he must orient the map. To orient means to adjust. Thus, to orient a map, you place it in a horizontal or flat position and then adjust or turn it until north, which is always at the top of the military map, is pointed toward north on the ground. When this is done, the symbols on the map will occupy the same relative positions that the features they represent occupy on the ground. In this way, you can locate and identify any visible features the map depicts, as well as determine the directions to features which lie beyond your range of vision. There are several ways to orient a map, but one of the fastest and most accurate is with a compass. This is a lensatic compass, commonly issued for use in the field. It takes its name from the magnifying lens, which is mounted in this arm. The most important features of this compass are first, a sighting device consisting of this sighting slot and this sighting wire, and second, a free-floating dial indicator. Although you can see that the dial has lines and numbers in both black and red, we will be concerned only with the red markings around the inner edge of the dial. These red figures indicate degrees, the most commonly used unit of angular measurement in map reading. A circle is divided into 360 degrees. If you stand in its center, these directions, as indicated by the degree marks, radiate out from you like the spokes of a wheel. The compass dial, due to lack of space, is marked in 5-degree graduations, and every 20th degree is numbered. The magnetic arrow on the floating dial always points to magnetic north, so each degree mark around the dial indicates a specific direction away from magnetic north. Thus, by looking out from the center of the circle, or sighting across the center and over a degree mark, you can identify a direction. By holding the compass to your eye in this manner, and lining up the sighting slot, the sighting wire, and your target, you can read the direction of your target. This direction, when referred to magnetic north, is known as the magnetic azimuth. Other features of this compass for use in daylight operation are first, this index line over the compass dial permanently aligned with the sighting slot and wire. This straight edge parallel to the line of sight. And this bezel ring, which with the crystal it contains can be rotated. When turned, the bezel produces clicks, and each click represents 3 degrees. A valuable feature for night operations. The first step in orienting a map with a compass consists of studying the map's declination diagram, which is found in the marginal information at the bottom of the map sheet. A declination diagram is placed on most maps to enable the user to convert a direction based on one north line, for example, true north, to a direction based upon another, such as magnetic north. This becomes less complicated once you recognize that 3 separate and distinct designations of north are encountered in using a military map. The first of these is called true north. A line from any position on the Earth's surface to the North Pole indicates true north. On a declination diagram, true north is symbolized by a star. However, when you use a compass, its arrow rarely points to true north because this arrow is attracted to or points to a magnetic area of the Earth which is located some distance from the North Pole. Magnetic north is indicated in the declination diagram by a line topped with half an arrowhead. Magnetic north is the reference used when working in the field with a compass. We can see then that true north and magnetic north are two of the three norths we must consider. The third designation of north on the military map is grid north. This is used when working on the map itself. As you know, the military map is printed with a grid, which is used for locating points on the map. For technical reasons, few of the grid lines which run from the bottom to the top of each map actually point to true north. Since grid lines are essential to use of a military map, their actual direction must be indicated for the user. Thus, the declination diagram includes a line which shows grid north. This line is symbolized by the letters GN. These, then, are the three norths encountered in map reading. True north, magnetic north, and grid north. To be of value to the map user, their relationship to each other must be known. This is what declination means, the angular difference between true, magnetic, and grid norths. In the declination diagram, the amount of this difference is indicated. It must be emphasized, however, that declination diagrams will vary with each map and may look more like this, or this, or this. When using a map with a compass, always begin by studying the declination diagram and analyzing the information it contains. Then apply this information to your individual situation. For example, in plotting a line on a military map, you will use grid azimuth, which is based on grid north. But a compass reading gives you magnetic azimuth. So before you can apply a compass reading to your map, you must convert from magnetic to grid azimuth. The declination diagram is used for this conversion since it shows the angular difference between grid and magnetic north, which is called the GM angle. The GM angle states the amount of declination and the direction from grid to magnetic north. In this case, magnetic north is a total of 15 degrees east of grid north. The GM angle will vary with each map. Here it is 5 degrees west, meaning that magnetic north is 5 degrees west of grid north. And here the GM angle equals 4 degrees west. Remember, the GM angle indicates only the declination or angular difference between grid and magnetic north. Now that we recognize the GM angle as expressing the relationship between grid and magnetic north, let us see how this information is used in the field. This man, as you remember, is about to orient his map using his compass. He has been studying the declination diagram and has determined the GM angle at this location. He now places the straight edge of his compass along any north-south grid line on the map and then rechecks the declination diagram for the GM angle. It is 5 degrees west, meaning that magnetic north is 5 degrees west of grid north. The soldier now carefully rotates the map, keeping the straight edge of his compass aligned with the grid line, until the difference in direction between the arrow of the compass and the black index line is equal to the difference in direction as shown in the declination diagram. In other words, when the map and compass have been rotated to a position where the arrow of the compass indicating magnetic north is 5 degrees west of the black index line, which indicates grid north, the map will be oriented. This is how the GM angle is used in orienting a map with a compass, and it is equally important in measuring directions once the map has been oriented. A direction is a straight line along which anything may be aimed, pointed, or moved. Direction is expressed in terms of angular measure, usually degrees. In map reading, the baseline used is always north. But which north is used? In the field, working with a compass, the baseline used is magnetic north. When working on the map with a military grid, grid north is used. In the field, using a map and compass, we must deal with two baselines in measuring direction, the magnetic and the grid. This is where the GM angle is important, for it is used to compute grid north from magnetic north or vice versa. To demonstrate how this works, let us assume that we wish to determine the direction of a point which lies out here. Direction, remember, is a straight line. So we draw in a direction line between our compass and the point with which we are concerned. In the Army, direction is expressed as azimuth, which is defined as a horizontal angle measured clockwise from a baseline. Azimuths are named for the baselines from which they have been measured. True azimuths from true north, magnetic azimuths from magnetic north, and grid azimuths from grid north. Since true north is not used as a baseline in determining direction with a map and compass, we will ignore that. In the field, magnetic azimuth is determined by sighting with your compass on an object whose direction you seek to establish. In this case, such sighting results in a compass reading of 80. This is the magnetic azimuth of our object. In converting this magnetic azimuth for use on our map, it is easy to see that grid azimuth is greater than magnetic azimuth by exactly the width of the GM angle, 15 degrees. Thus, to find grid azimuth for map use, add the GM angle of 15 degrees to the magnetic azimuth of 80 degrees, and you obtain 95 degrees as the grid azimuth. When magnetic azimuth is less than grid azimuth, add the GM angle. Elsewhere on Earth, the magnetic azimuth may be greater than the grid azimuth. So the GM angle of 15 degrees, as shown on the declination diagram, is subtracted from the magnetic azimuth. This gives us a grid azimuth of 80 degrees. To go from map to compass operation, you convert grid azimuth to magnetic azimuth in the same way. Here, grid azimuth is 95 degrees. Since magnetic azimuth is obviously less than grid azimuth, you will subtract the GM angle of 15 degrees from the grid azimuth of 95. Thus, the magnetic azimuth is 80 degrees. This, then, is how you convert grid azimuth to magnetic azimuth and vice versa. Study and practice with declination diagrams will enable you to use the GM angle for this purpose easily and rapidly in the field.